So hopefully you had enough time to do this. It was just graphing it is what we did yesterday. So remember, whenever you're graphing and it gives you a table, all you need to do is take these numbers, plug them into here. So hopefully that's what you did. Did you guys get these values? What did you get for -2 for y?
-12.
Nice, okay. Yeah, -12, and the way that goes is you should have done -3 times -2 all squared. Then PEMDAS says square this first. Hopefully you said -2 all squared is 4. If you're still saying -4, bad job, you guys. This should be -2 all squared. -2 times -2 is +4 times -3 is -12. That's how that came to be. All right, then you do the same thing for the rest of these. So I don't think I want to go through the whole work. So, but what'd you get for -1 for the y value? -1 y value, what'd you get? What'd you get? -3 sounds right. All right, 0, what'd you get? And then for 1, yeah, you should notice that these are symmetrical, so this should be -12 as well. All right, very cool, very cool. And then you graph this and you get an interesting shape. So that was 0, 0. -2, -12 is off the graph, so like down here somewhere. I guess I'll try to estimate. -1, -3 is right here. 1, -3, and 2, -12 is down here. You get a really, really narrow parabola. There you go, there you go. Again, this shape is called a parabola, the U shape. And then it asks you to identify these 3 things. You guys remember what the vertex is? Yeah, 0, 0. That's the point, the like middle of the point where the parabola meets, basically. The highest point is what we said yesterday, or the lowest point, if it's opening up. Okay, axis of symmetry, you guys remember that? Nice, you guys, good job. Yeah, this is just the line that cuts it in half. So that's the line x equals 0. And then this opens down, obviously, but do you guys remember how I could have known that without graphing?
Negative.
Nice, nice, nice. Good, yeah, good job. The -3 out here, if it's a negative in front, a negative coefficient, then you know it's going to open down. Yay, okay, good job. Okay, next, you'll have to watch me mess with Desmos sliders again. So let me get to that. Whoa, they changed it. Now blue. All right. It says ax squared plus c. Okay. So everybody learn, get off your phones, learn from me, watch this. So right now I have 2 graphs graphed, but it's the same thing because one of them is 1x squared plus 0, the other one is just x squared, so they're the same thing. But what happens as I mess with these numbers? So we know that this A guy just affects how intense the parabola curve is. So like it makes it narrower or wider depending on how big the number in front is. But what about the C? Watch what happens as I mess with the C. So purple is just the most basic parabola, the parent function x squared. Let me get this to 1. Okay, there it is. All right, like I said, purple is just the most basic parabola. What happens if I add to it? You can probably guess. Whoa, whoa, whoa. Whoa, awesome. Okay, so what's happening as I mess with the C value? What does it affect? Yeah, exactly. It moves the vertex up or down. That's a good way to put it. Moves. Yeah, sure. Moves the vertex up or down. This is actually, yeah, okay, that's fine. I was going to say a proper word for moves, but I'll say for the next 2. All right, how's the graph of x plus 2 compared to the graph of x squared? So here's x squared in purple. Oh, this is almost x plus 2. All right, how does it affect it? What's the difference between this purple and this red? Yeah, the red one was moved up by 2 units. So when you add 2 to the end of it, it moves it up by 2. Oh, okay, that should make sense. You're just taking this same function and then moving every point. Like you're adding 2 to each point. So that where you were at 0, now you're at 2. Where you were at 1, now you're at 3. You're just moving everything up by 2. That should make sense. You're just adding 2 at the end. Okay, cool. So the graph of x here, we'll say x plus x squared plus 2 is moved, but I'm going to say it more formally so you guys get used to this, is translated of by 2 units. Okay, and then I'm not even going to show you this. How do you think x squared minus 5 is going to compare to x squared? Like, what will be the difference between x squared minus 5, that graph, and the parabola of x squared? Yeah, exactly. You're gonna the whole parabola is just gonna get moved down because you're just taking this graph and subtracting 5 from every point. In other words, watch this. If I go to minus 5, there it is. We get the same graph, but moved down by 5. That should make sense because you're just taking every point on here, the x squared, and then you're subtracting 5 from each point. So where you used to be at 0, you're now at -5. Where you used to be at 1, you're now at -4. Where you used to be at 4, you're now at -1. You're just moving everything down by 5 because you're subtracting 5. That should make sense. Okay, so x squared minus 5 is translated down. Five units. When compared to the parent function, the most basic parabola, x squared. And then, well, this is, I already was talking about what translated mean, but these are called vertical translations, like formally. So if you hear that in other math classes or you hear me saying it, that's what it's called. I'm just moving it up or down, vertical translation. Okay, then the next bit is just about like, can you graph this yourself using tables? Can you graph that yourself using tables? And then here, depending on how much time we have left, I might stop. Because these next two just have you plugging in a bunch of points, but that's tedious and annoying. I don't want to plug in 5 points here, 5 points there, make my little graph. There's a way to just look at this and be like, okay, I think this is going to basically be what it looks like. And it just has to do with shifting it down by 6, and I'm multiplying it by 2, which makes it like skinnier. So you can kind of know what it's going to look like without having to plug stuff in. But for now, we're plugging stuff in. Okay, so let's do that. -2 into here to find out what the y value is would be -2. Oh, shoot. Sorry. I'm just reading this. So that would be 2 times -2 in for x squared minus 6. All right, you could put this in your calculator, but I think that's just going to be a waste of time. It's easier to do it in your mind. So watch this. PEMDAS says do. Oh, yeah, what's up? Oh, yeah, exactly. Good. Okay, so this would be PEMDAS says do the squared first. So -2 squared is 4 times 2 is 6, and then minus 6 would be 2. So correct. You should get 4 first, then times 2, then minus 6. You get 2 at the end. Okay, do the same thing for all of these. All right, take like 5 seconds, decide what you think that number is. And then what did you get? What do you guys get for -1? I got -4, right? -1 all squared is +1 times 2 is +2 minus 6 is -4. And again, you could do these in your calculator if you wanted, but I just don't think that's super necessary. All right, do the same thing for 0. The nice thing about 0 is like this is just going to be 0. So 0 squared is 0 times 2 is 0. So you just get -6. And then do the same thing for 1 and 2, but in this case we're kind of smiling because we've seen that these are just what's it called, symmetrical. So down here I'll just get these two numbers in these particular cases. But the safe thing to do is just check anyway. So 2 times 1 squared minus 6 is going to be, well, 2 times 1 squared is 2 minus 6 is -4. And then 2 times 2 all squared minus 6 should be, okay, one more time, 2 squared is 4 times 2 is 8 minus 6 is 2. You just have to do it in the right order. You should get these numbers. Nice. Okay, now we graph these guys. -2, 2. -1, -4. 0, -6. 1, 4, 2, 2. Hello. Now look at this parabola. Whoa, awesome. Okay, cool, cool, cool. All right, now remind me, what's the vertex? Yeah, -6 is right here. It's not just -6 though. Yeah. It should be 0, -6, that point. Then the axis of symmetry, what's that? No, be careful. That would be, you're looking at a line like this. Yeah, x equals 0, 0 is on the x-axis. It should always match the x coordinate for our purposes. Like for our class, Algebra 1. Okay, and then this opens up. Obviously, it's opening, like, the U shape is facing up. And that's because there's no negative out here. Okay, so see if you can get this one. And let's say you take 5 minutes on that. It would be 9:07. You guys leave at 9:21. Yeah, I think we might have time for this. Yeah, we do have time. Okay, cool. And then we'll save the last thing for later. Okay, so take 5 minutes on this. I'm going to take attendance. Oh, sorry, it's right there. Yeah, well, the negative we just learned that so you can see graphs opening down. Oh, and the transformation is called a reflection with the x-axis. No, you gotta say that. Say the explanation and say reflection over the x-axis, or just wait for us all to do it. Did I set a timer? Rats. Okay, it's probably been like 3 minutes, so take 2 more.
Oh. I think I forgot.
Are you guys learning? You guys doing the graph? Good job. Good job, Dave. All right. Yeah. Yeah, more like I import this, like import stuff. I mean, look, native tweeters to that, and around whatever you're plugging in. So instead of the and put parentheses, whatever you're doing.
You sit up class.
Okay, all right. I'll be right here.
That's just gonna where. And then
That's funny when you guys are.
all right, take another minute. Yeah. Oh, because of the. Yes, hurry, but try to be back in time because.
Don't talk to me anymore.
Negative. You see what this negative is? It's negative, then I plugged in negative 2 squared plus that negative 2 plus that. That'll change that, yeah. And you do the same thing for the rest of the month, stick around.
Oh, negative.
Yeah, the negative almost, that's what it was. All right. So let's go through these. I don't have my key, but I trust you guys. What did you guys get for negative 2 for the y value? I got 3 as well. All right, what'd you get for negative 1 for the y value? What'd you get?
I got 3.
I think it should be 6.
We got 11.
Oh my gosh, you guys, okay. You take these numbers, you put them instead of the x, and then you find out what number that is. So you take, I'm just rewriting this function, but instead of an x, it's a negative 2 in parentheses. That should be negative 2 squared plus 7.
I did negative 1 instead of x. I got double. I get all the same.
Yeah. Whatever you were doing was working. Okay. So then this would be, well, negative, okay, now you follow PEMDAS. So PEMDAS says do the exponents first, then multiplication, then add 7. So exponent first, negative 2 squared. If you say negative 4, I will scream. What's negative 2 squared?
8. 4.
Yeah, just normal 4, normal positive 4. So this is just 4, then negative 4 plus 7 is 3. That's this 3. Caden Curia, you're the one that asked about this. Did you understand how I got this 3? Okay. Then you do the same thing for negative 1 and you should get 6. You do the same thing for 0, you should get 7. And then 1 and 2, this is symmetrical, so this should be 6 and 3. Okay, so then your parabola looks like 0, 7, negative 1, 6, positive 1, 6, negative 2, 3, positive 2, 3. And it looks like this. Nice looking parabola. Okay, cool. And then now you identify the vertex axis of symmetry and which way it opens. So which way, what's the vertex here? Guys, help me out for one more problem. What's the vertex?
0.07.
Okay, good job. Yes, this entire point. Don't just say 7. Vertex is 0, 7. Good job. Axis of symmetry is this line, which I say how. The x equals 0. Good job. And then this opens. Nice. And remember, you could have known that because of the negative out here. Okay, now this last bit, I really want to explain each one, so I don't think I want to rush through that in 11 minutes. I think I want to take my time through that. So let's save this for tomorrow. I think you'll get more out of it. So don't lose these packets, and then you'll turn in tomorrow, you'll turn in the very last page of it. But I'll remind you again tomorrow. Don't lose the packets, please.
I'd be like an attempt because I'm tracing Jordan to sticking through it.